Hello Tanga, welcome to GullyClassroom. This is the first lecture in which chapter sir? In the chapter circles in CBSE 10th standard mathematics chapter circles. This is the first lecture that is taken in English. If you guys want to listen to the Tamil version of the same lecture, that is also available in the same playlist under the title T1 Tamil first lecture. Okay sir. What about this particular lecture? Under what title will this be available? This will be available as E1 English first lecture. Okay sir. Without wasting any time, please do start the lecture. Absolutely Tangam, but before starting the lecture, let me give you a very short introduction of what you are going to learn in this particular first lecture. Okay sir, please do so. In this particular first lecture, you guys are going to learn what is a circle, what is a tangent to a circle, what is a secant to a circle, what are some beautiful properties of tangent to a circle. Then we will learn a property, about a tangent. What property sir? Tangent and radius are perpendicular to each other. After that, we will work some 1 marks, we will complete some fill in the blanks, and then we will do a couple of problems and finish off the lecture. We will finish off the lecture with a couple of beautiful problems. Okay sir. Do start the lecture immediately. Okay Swami. Come on, follow me. What is meant by circles? A circle is nothing but a collection of points which are at the same distance from a fixed point. Let us take this as a fixed point. So a collection of points which are at the same distance. The same distance is in fact called as R. R is called as the radius of the circle. The fixed point is called as the center of the circle. The fixed point is called as the center of the circle. So, what is the circle? A collection of points that are at same distance. What is that same distance? It is nothing but R, small r, which is the radius of the circle, from a fixed point which is called as the center of the circle. Fine sir. Now please tell me what is meant by non-intersecting line. Any line that is not cutting the circle at any point is called as a non-intersecting line. Intersecting simply means to cut. Okay. What is meant by a secant? A secant is nothing but a straight line that cuts the circle at 2 points. A secant is nothing but a straight line that cuts the circle at 2 points. So, for a circle and a secant, there are 2 common points. How many common points are there between a circle and a secant? Exactly 2 sir. Sir, I am noticing something very interesting over here. Can I share it with you? Absolutely Tangam, please share it with me. Let us say you are moving the secant slowly towards the end of the circle, slowly away from the circle. Can you notice what is happening sir? Okay, let us try to move. Okay, let us try to move this particular secant towards the end of the circle. Let us try to move this particular secant towards the end of the circle. What is happening? The 2 points where the secant is cutting the circle, the 2 points where the secant is cutting the circle are slowly getting closer to each other. The 2 points where the circle is cutting the secant is slowly moving and coming closer to each other, and right at the end of the circle, the line is cutting the circle only at 1 point, and this particular line which cuts the circle only at 1 point is called as a tangent. Okay sir. Before you tell more points about the tangent, please tell me what is a chord. A chord is a very simple idea. A chord is simply a line which is going to touch the circle at 2 points. That's it. A line which is going to touch 2 points of a circle is called as chord. All these lines are called as chord. Why sir? Because they move from one particular point on the circle to another particular point. They do not cross the circle. A secant can cross the circle. A secant is in fact a ray which is cutting the circle at 2 points, but a chord always moves from one end of the circle to another end of the circle. Okay sir, let me ask you something totally interesting. Yes Tangam, which is the largest chord in a circle? The largest chord in a circle is nothing but the diameter. This is the center of the circle. Whoa, the largest chord of the circle. Here the length is r, here the length is r. So the largest chord of the circle is diameter, and the length of the diameter is nothing but 2r. The length of the diameter is nothing but 2r. Okay sir, now do read the definition of tangent and please continue the class. A tangent is a special case of a secant. So a tangent is nothing but a special case of secant. How? When the secant is moving away from the center, when the point of intersection, the 2 points of intersection of the secant move closer to each other and coincide, when the two endpoints of the corresponding chord, you are considering these two as a chord, you are considering the line in between these 2 points as a chord. So the two endpoints of the chord are slowly moving closer to each other and coinciding when the secant is moving away from the center, when the secant is moving towards the end of the circle. So a secant is nothing but a special case of a a tangent is nothing but a special case of a chord. A tangent is nothing but a special case of a chord. Okay sir, okay sir. What next? So we will next learn about concentric circles. What is meant by concentric circles? Concentric circles are nothing but circles which have the same center. Okay, but each circle has different radius. In this case, this particular first circle has radius r1, this particular second circle has radius r2, this particular third circle has radius r3. Here the concentric circles, 2 or more circles which have the same center but different radius, Okay sir, I am able to understand all these particular points. I have just learnt about what are concentric circles. I know that the entire length of a circle is called as circumference of a circle. I also know the largest chord in a particular circle is nothing but diameter length is 2r. I also know that a tangent which cuts the circle only at one point is nothing but a special case of a secant. A secant which actually cuts the circle at 2 points, when moving away from the center, the two points? The two intersecting points slowly move closer to each other and meet each other at one particular point, and the secant is becoming a tangent at that particular point. Sir, let me ask you a question. Please do ask Tango. What is that particular point where a tangent is getting formed on a circle called as? That is called as point of contact. That is called as point of contact. The common point between the circle and a tangent. Let us say this is a circle. The common point between a circle and a tangent is called as point of contact. So here I have drawn 4 tangents. So this is one point of contact, this is another point of contact, this is another point of contact, and this is another point of contact. Obviously, here there will be a center which is always indicated by the letter O. Okay sir, what next? What are the other main properties of a tangent? Absolutely, let us go. A tangent intersects the circle only at one point. Okay, for each and every point on a circle there can only be one tangent. Absolutely. Here, look at the beauty of this thing. At every single point, a circle and the tangent is monogamous. At that particular point, for every husband there is only one wife, which means at that particular point, for every circle there is only, at that particular point there is only one tangent. At that particular point there is only one tangent. Okay sir, I am comfortable with this insane idea. Let me repeat myself. Every circle, each circle may have infinite number of tangents. How sir? Let me do a very small illustration. Each and every circle can have infinite number of tangents. Let us take a circle. For this particular circle with center O, I can draw infinite number of tangents. For each and every point on the circle, I can simply draw a one tangent. For each and every point on the circle, I can simply draw one tangent. So there can be infinite tangents drawn for this particular circle. But let me repeat myself. But for this particular point, this is the only tangent. For this particular point, this is the only tangent. For this particular point, this is the only tangent. For a given point, each circle, for a given point, the circle has only one tangent. But the circle in general has infinite number of tangents. Are you able to understand the difference? Are you able to understand the difference? At a given point, there can be only one tangent. But each circle will have many points, a million points, 1,000 points, and each and every point will have single tangent. A circle can have 1,000 points. A circle can have 1,000 points. Each and every point on the circle can have one tangent, which means each and every circle can have so many different tangents. Are you able to understand the idea here? Yes, sir. Yes, sir. Let me repeat once more. For a given point, there can be only one tangent, but for a given circle, there are many points on the circle. Each point will have different tangents for a given circle. So, for a given circle, there can be infinitely many tangents. Okay, sir. Okay, sir. What next? There can only be two parallel tangents. There can only be two parallel tangents for a circle. How am I supposed to illustrate this, sir? Okay. This is how we are going to do the illustration of this particular thing. Let us take a circle. Let us have a tangent. Okay. You need to do a parallel tangent to this particular tangent 1. How are you going to do a parallel tangent to this particular tangent 1? Let us draw parallel lines like this. What is happening at this particular point, right at the opposite of this particular line? What is happening? I am once more getting a tangent. So there can only be two tangents, two parallel tangents to a circle. There can only be two parallel tangents to a circle. In fact, let me tell you something totally interesting. Yes, sir. If there are two parallel tangents to a circle, if I contact this, if I join this point of contact with this point of contact, what will happen? I will be getting the diameter. I will be getting the diameter. If there are two tangents which are parallel in a circle, if I join this particular point of contact and this particular point of contact, it will pass through the center O. It will pass through the center O, and I will be in fact getting the radius. Okay, sir. Okay, sir. What next? We have seen almost all the concepts and theorem with respect to circles. The next thing we need to see is the theorem where we are going to study how a tangent is perpendicular to the radius. Sir, do tell how a tangent is perpendicular to the radius. First, let us read the statement. A tangent at any point on the circle is perpendicular to the radius through the point of contact. So here there is a tangent. Here there is a tangent. This particular tangent is drawn at any point P, and it is said to be perpendicular to the radius. It is said to be perpendicular to the radius. We need to prove this. How are we going to prove it? Okay, let us do this. First, what is given? A circle with center O is given. Fine. OP is the radius. So OP is the radius. OR is also the radius. OP is the radius. OR is also the radius. XY is a tangent. P is the point of contact. How are we going to start our proof, sir? The proof will start with the point Q. The point Q is in fact lying outside the circle. The point Q is in fact lying outside the circle. Yes, sir. So, what's the big issue? So, OQ, the length OQ can be written as the sum of the length of OR and RQ. So, OQ is equal to OR plus RQ. OQ is equal to OR plus RQ. Here, OR is nothing but the radius. The OR is nothing but the radius of the circle. So, I am going to substitute small r for the length OR. Okay, sir. What next? Here, because of this illustration, I can understand that the length OQ is greater than the length OR. Why, sir? Because in the length OQ, there is an excess RQ. Okay, so OQ is greater than small r. OQ is greater than small r. Fine sir, fine sir. OQ is greater than small r. I am going to replace small r with OP. Why sir? Because OP is also radius of the circle. Because of this, from the diagram itself, I can understand that the length OQ is greater than the length OP. The length OQ is greater than the length OP. Okay sir. Now, how am I supposed to progress this particular idea even further? Now, let me move my point to Q towards P. Let me move the point to Q towards P. What will happen? Let us try to draw diagrams and illustrate this. Sir, please draw neat diagrams. I need to understand this particular theorem very clearly. I am sorry Tango. Let me draw very neat diagrams. Let me use blue color once more. Hopefully I will get neat streaks of lines. Yes, I am getting neat streaks of lines. And that is nice and beautiful. Okay sir, what are you getting here? Tango, as the point to Q is moving towards P, the length RQ is decreasing. Are you noticing this? As the point to Q moves towards P, what is happening? The length of RQ is decreasing, and right at the point to P, what is happening? The length of RQ is becoming 0. The length of RQ is becoming 0. When moving from Q to P, excess RQ is disappearing. It is becoming 0 only at P, which means OP is the shortest distance. OP is the shortest distance between the point O and the line XY, which means, sir, I think I know something interesting. Please do share it with me, Tango. I studied in 9th standard that the distance between a point and a line is nothing but a perpendicular. What distance? The shortest distance, sir. The shortest distance between a point and a line. A shortest distance between a point and a line is nothing but a perpendicular. Where did you study this, Tango? I studied it in 9th. Very good. Do you remember this particular theorem? The shortest distance between this particular point, the shortest distance between this particular point and this particular line is nothing but a perpendicular. So, if OP is the shortest distance between this particular point and this particular line, it has to be a perpendicular. It has to be a perpendicular, and hence proved. What did you prove, sir? I have just proved that OP radius is perpendicular to the tangent XY. OP radius is perpendicular to the tangent XY right at the point P, right at the point of contact. Okay sir, okay sir. So the shortest distance from the point O to the line XY is always a perpendicular. So radius is perpendicular to the tangent. What about a couple of corollaries, sir? Okay, let us look at a couple of additional statements that we can take away from this particular theorem. We have just proved in this theorem that the radius is perpendicular to the tangent. I want to take a couple of more corollaries from it. Can we do so? Absolutely, sir. Come on, Tangam. There can only be one tangent at a point on a circle. Absolutely. There can only be one tangent at a point on the circle. Why? At each and every point, I can only draw one shortest distance from the center. Here, the radius is literally the shortest distance that is touching the center and the tangent. Here, the radius is the shortest distance that is touching the center of the circle and the tangent. Are you getting this point? Absolutely, sir. Absolutely, sir. OP is equal to normal to the circle at the point P. Sir, what is this particular idea? Here, OP is called the normal to this particular circle. Sir, I think I have studied normal somewhere else. Kindly recall, you have studied the concept of normal in spherical mirrors. In spherical mirrors, you studied that the normal always passes through the center of curvature, which is in fact the center of the sphere from which you are going to get the spherical mirror out of. So, the normal of the spherical mirror is nothing but a straight line that is going to pass through the center of a sphere. Sir, I think I need to recall this concept more. Which concept, Tanga? The normal concept. don't worry, you can simply learn more about normal in our channel itself. How, sir? Simply in search, type in spherical mirrors, GullyClassroom, first lecture. Spherical mirrors, light, reflection, spherical mirrors, GullyClassroom, first lecture. In the first lecture itself, what will I study, sir? You will study about spherical mirrors. In that spherical mirrors lecture itself, what will I study, sir? You will study about normal, how normal is always passing through the center of curvature, how center of curvature is nothing but the center of the sphere from which you are going to get the spherical mirror out of. Okay, sir, thank you. I will go and study there. Okay, can we continue this particular lecture and finish up these some 1 marks and problems? Absolutely, sir. Let us go for the first question over there. How many tangents can a circle have? A circle can have infinitely many tangents, sir. How, Tangam? Sir, look here. This is a circle. In this particular circle, for each and every point, I can simply draw a tangent. For each and every point, I can simply draw a tangent. In fact, I can take a new point here, draw a tangent like this. I can take a new point here, draw a tangent like this. I can draw so many tangents, sir. So, the answer for this is infinitely many tangent. Infinitely many. What next? Fill in the blanks. Let us look at the first fill in the blanks. A tangent to a circle intersects it at just one point. Why, sir? Because the radius is the shortest distance between the center of a circle and the tangent. So it is going to intersect just at one point. A line intersecting the circle at 2 points is called as secant. Okay, sir. What next? Let us go for the next one. A circle can have dash parallel tangents at most. Not an issue. A circle can have two parallel tangents at most. A circle can have two parallel tangents at most. The common point of a tangent and a circle is called as point of contact. It is simply called as point of contact. Okay, sir. What next? Let us do this particular problem, Tangam. Let me read that problem. While reading, let me also rub this particular space in order to do that particular problem. A tangent to PQ. So you are drawing a tangent PQ. Where are you drawing a tangent PQ? A tangent PQ at a point P. Okay. So let me draw a circle like this. Fine. Here there is a tangent PQ. So here at the point P. Where is the point P present? Point P of the circle. So point P is present in a circle with center O of radius 5 centimeter. So here the radius is 5 centimeter. What next? Meets a line through the center O at point Q. So this particular tangent is meeting a line through O. At which point it is meeting right at Q. Okay, sir. What next? So that OQ is 12 centimeters. They are telling that OQ is 12 centimeters. They are asking for the length of PQ. I am going to assume the length of PQ as X. Just now, before a couple of minutes, I proved in this particular theorem that the tangent and radius are perpendicular to each other at the point of contact. So I am going to put right angles over here. Here the radius OP is perpendicular to the tangent PQ. Because this is perpendicular, I can write Pythagoras theorem. In right angled triangle OPQ, what is happening in right angled triangle OPQ? Which is the hypotenuse, sir? The side opposite to the right angle. OQ square is equal to OP square plus PQ square. Let me substitute all the known values. OP is nothing but 12 square, which is equal to, am I getting this right? Yes. PQ. OQ is nothing but 12 square. Okay. OP. What is OP? OP is nothing but 5 square plus what is PQ? I need to find PQ. In fact, PQ is assumed as X. I can write it as X square. So 12 square is 144, which is equal to 25 plus X square. I can take X square over here. So 144 minus 25, which is equal to X square. Let me continue over here. X square is equal to what is 144 minus 25. Okay, it is 119. Let me think. Yes, it is 119. If I take square root on both sides, sir, what is square root? Sir, square root is nothing but you are going to take a power of half. Square root is nothing but you are going to take a power of half. This 2 and half will get cancelled. So x can be written as 119 power half. 119 power half can be written as root of 119. So x is equal to root of 119 centimeters. So answer is D. They are asking for the length PQ, which is assumed as x. So x is found as root 119. Fine, sir. Fine. Now let us go for the last problem of this particular lecture, which is the fourth problem. Before that, Tangam, have you guys noted this down? Absolutely, sir. Please continue. Absolutely, sir. Please continue. Okay. Let me rub this off. Yeah. Okay. Let us go for the fourth problem. What am I studying in the fourth problem? Draw a circle and two lines parallel to a given line. Okay. Let us say this is my circle. This is the center O. Here I am going to draw one line over here. This is my given line. Okay. I need to draw two lines which are parallel to the given line such that one is a tangent and another is a secant. So I need to draw one secant that is parallel to this line. Let me draw a secant. This is my secant that is parallel to the given line. Okay, I need to draw a tangent that is parallel to this line. Let me draw a tangent like this. That is basically very easy. Child's play. Am I right or wrong? They just want to test you whether you are getting an idea that you can draw how many tangents to a given line. To a given line, you can draw two parallel tangents. But what about secants? You can draw infinite number of secants. That are parallel to a given line. Yeah, because all these secants cut the circle at two different points. Yeah, that's basically the end of this lecture. I had so much fun taking this particular lecture to you guys. Yeah. At the end of this lecture, I have given some very beautiful problems that are based on circles and tangents. Do try them in order to get a better idea of this particular chapter. Obviously, if you guys like our videos, subscribe to our channel, click the bell icon, recommend our channel to your friends through WhatsApp, through Instagram and through other social media applications like Facebook, because we are going to have so much fun learning physics, chemistry, biology, history, geography, economics and each and every other subject of each and every standard has